Hello, class. I'm with you. Just give me 2 minutes. Thank you. Okay, so please, those on YouTube, can you please say hello if you can hear me very clear? Those on YouTube, please. All right, can see. And those on Zoom, can you also do the same, please? Just few people I need, that's all. Okay, that's okay. So sorry, so sorry, so sorry, so sorry. I notice you can't hear me. Now you can hear me. Actually, I didn't say much. I didn't say much. So sorry to those on YouTube. Sorry to those on Zoom. Actually, I didn't say much. What did I say? I just did a recap of what we did last week. It was a very quick recap. So sorry, I was not watching people raising their hands. So let me still do the recap quickly. It wasn't much, really. I just looked at what we did last week. So last week, I was saying that we looked at computer processing modes and computer networks. Then under computer processing modes, we looked at the various examples. And we told ourselves what processing modes are. There are the different modes under which the CPU, that's the brain of the computer, operates and manages access to system resources. And we mentioned them: the user mode, supervisor mode, kernel mode, protected mode, real mode, etc. Each mode comes with its privileges and its limitations. So that was what I was saying, that you aren't hearing me. So don't cry. You have not missed much. Then we also looked at data processing. That was last week. And data processing is what the art of collecting your raw data and translating it into or converting it into a form that is usable, a form that is meaningful. And we listed the steps, which is common sense. The steps are: you collect the data, you prepare it for processing, you input it in the computer system, you now process it, you get your result output, and then you can store. That was the steps involved. And then we moved our types of data processing, stuff like batch processing, real-time processing, online processing, distributed processing, and the other one is time sharing. Each one I dedicated a slide to it, and each one had a takeaway, as in what you will use to know or define it. For batch processing, we are talking about what? Processing large amounts of data in bulk. Large, that's a key word there. In bulk, that's a key word. The third one is what? Under a scheduled time. You are not processing it anytime, but there's always at a scheduled time you process that large amount of data in bulk. We gave examples of batch processing. We came to real time, the same. The name real time already is talking about something you're doing right away. So under real time processing, we talked about data being processed instantly as it is being received. And the outcome or the output is almost instantly received. Online, that was a key word for online. Online processing is internet. Internet must be involved and a computer equipment. And that's the subtle difference between the online processing and real-time processing. And the others also distributed processing, time sharing processes. So I'm just a quick recap. So after batch processing, if I remember very well, we now moved to computer networks, and there were so many examples of computer network. We called LAN, local area network. We called WAN, wide area network. We called wireless WAN, that's wireless LAN, that's wireless local area network. We talked about extranet. We talked about intranet. We talked about VPN, that's virtual private network, and others, personal area network. So I took time to explain each one of them and examples. And I think finally we looked at components of a computer network, stuff like the nodes. And we are told that nodes are any device that can be connected to the internet, not just your laptop, not just your computer, but also your mobile phones, printers, any device that can be connected to the internet. All right. What else? No, so we looked at stuff like router, switch, hub, modem. And I remember drawing a little diagram to show the subtle difference between router and switch. They are doing the same thing, but at a different scale. I'm getting a message from WhatsApp that they are not hearing me, unless it's an old message. Please, can you hear me? Please. Can you hear me? Yes, sir. So apologies again to those that weren't hearing me before, but as I said, you didn't miss much. I have not started the lecture. So if you can hear me on YouTube, please, can you Say yes, sir. Don't be on Zoom and be writing on YouTube that you're hearing me. You see, purely for those on YouTube, I'm asking this question. So you can hear me. So 1 minute, let me just reply this person. That's hello, my mic is not muted. Lecture has already started. Maybe you are just waking up. Thank you. Okay. All right, so let me share my slide for today. 1 minute, please. One minute. Let me share it. All right. And I hope you can see my slide now. Sorry for continuously asking you this question, but I have to be sure that everybody's following. You see, that's why we always ask, are you following? Are you following? And it now be sounding boring. Why is this man always asking? You see, I didn't ask and I started, and the people were not hearing me. So please, can you see the slide? COS 101, lecture 6. Can you see it, please? All right, so let's start. All right, thank you. So we start. Today we are looking at information representation and computer number system. By computer number system, we are talking about different number systems used to represent information that is, of course, at the end of the day, converted to the computer language, which is binary. But you have others, hexadecimal, octal, and the decimal system. Decimal system is what you and I use. 1, 2, 3, 4, 5, 6, 20, 25, 26. These are decimal. Why binary are 0, 1? So we'll come to that. So let's first look at information representation. By information representation, ladies and gentlemen, I'm referring to the different ways data and knowledge can be organized, structured, and displayed so that computers and you humans can understand and process them efficiently. Different ways, your data, knowledge, whatever, can be organized, structured, and displayed so that computers and humans can understand and process them efficiently. So it involves encoding real-world concepts into a format that can be processed by humans or machines. And there are different types of information. Different types of information requires, different types of representation. Some information can be represented in another form, others can be represented in a different form. So what are the different types of information we have? We have text, T-E-X-T. We have numbers. We have images. We have audio. We have video. These are all kinds of information. We have diagrams and more. They require specific representation methods. The way you represent audio might not be the way you represent numbers. So that is why we have different information representation methods. Okay. We have it on the screen. We have two screens. If you check your manual, these are just what I listed there. I have two screens, this first one and this second one. So this is just a continuation. Bits and bytes. So I dedicated a slide to each of them. Bits and bytes, we talk about it so quickly, each of them. Binary representation, character encoding, numeric representation, text representation, image representation, audio, video. Next slide, data structure. They are still continuation. Database representation, graph representation, Boolean, algebra, machine code and assembly language, semantic representation, and maths notation. So we are going to look at them one after the other. So today, you'll be having a slide that has a material that has so many slides. But don't be in a rush to say, this is too much. You will see that each of them just has 1 or 2 sentences. So each of the slides will have 1 or 2 sentences or no sentence at all. So within 30 seconds, I should be able to go through each and every one of these. I believe that everybody listening to me now did maths in YX/NECO. Might not necessarily be in JAM. So if you did it in YX/NECO, you should be able to understand some of the things I'm going to talk about, like numeric representation, like binary representation. At least you should be able to. Then some kind of Boolean algebra and graph representation, and also mathematical notation. These, you'll be hearing them while you are in secondary school, provided you used to go to school. Okay, so if you are not going to school, you'll not be able to. Yes, 30 seconds I will use to explain each and every one of them. I'm even giving you a grace of 30 seconds. I should just mention them and ask you to go and read it in the manual. And that's all. Okay, so see how we are going to move. These bytes, binary representation, character encoding, and the person, sorry, I'm saying 30 seconds. I think it's Mr. Ibrahim. Please note, you are in a university. You are no more in secondary school where everything you are being spoon-fed. You put food on your spoon, give the spoon in your hand, and use your hand, push your hand into your mouth. No. We now put spoon on the plates. Go look for your spoon. If you don't have spoon, go and beg. Then use your own hand, scoop the food from the plates, and then eat it. So it's a university. We have to just give you guidelines, tell you what to focus on, what not to focus on, where to pay attention more, and au revoir. That's in French. Bye-bye. So if someone is going extra mile to explain little, you should appreciate that. But I understand they are still new in the university, so you expect everything to be... Wait, now second semester, you want to go see them now, how it is done. It's a little bit faster. Okay, so bits and bytes. So let's see, let me go back. This is how we are moving. I will look at bits and bytes. Next, I will look at binary representation. Next, I will look at character encoding, and we will be moving that way. We'll be moving that way. Okay. Okay. So information representation, I say it again. Someone just asked. The message just popped on my screen. But remember, once I start presenting, I will not be looking at questions you're asking. And remember our rule, put down your questions, send it to your course rep. Like last week, I got some questions and I answered. Send it to your course rep at the end of the lecture. I will answer it once I'm chanced. But, you know, you guys are more than 4,000. So you can imagine each person asking question. So I said information representation refers to the different ways data and knowledge can be organized, structured, and displayed so that computers and humans can understand and process them efficiently. So different ways you can represent your data. That is how you will organize it, how you structure it, how you display it, such that you, the human being and computer, will be able to understand and also process them efficiently. That is it. And these are them: bits, bytes, binary representation, etc. So we go to bits and bytes. There's a little thing I wrote there on the left. That bits is the fundamental unit of digital information. Just like, let me use some SI units. I hope I will not make a mistake. It's been long I left secondary school, but I know that these are one of the things you are always forced to cram in secondary school, the SI units of all these measurements. The SI unit of time is what? Can someone write it on the screen, on the chat, both on YouTube or on Zoom? Exactly. Exactly. Second. So I want to use that knowledge to tell you what bit is. But we don't say the SI unit of digital information, but that is what it means. Ladies and gentlemen, the SI unit of digital information is bit. So that's the meaning of bit. Bit is the fundamental unit of digital information. What do I mean by digital information? Any information that can be represented in a computing system. Paper is not digital information. Anything you wrote on paper is not digital information. Anything you molded, image you molded is not digital information. But anything you can view on your screen, or the music you can listen to, the video you can watch, the text you are writing, the diagram you are drawing, these are digital information. So when you hear about digital information, don't think about that it's just text you wrote. No, audio, video, image, text, numbers, signs, symbols that are in a computer. Not that you wrote text on paper or you wrote number on paper. No, it must be represented in a computing system. These are what we call digital information. So the SI unit, but I don't want to be quoted that I'm saying the SI unit. The fundamental unit of digital information is the word bit. And bit represents 0 or 1. So a bit, ladies and gentlemen, is the smallest unit in computing and represents a single binary value, 0 or 1. That's what a bit represents. No 2, no 3, no 4, 0 or 1. Whereas a byte, B-Y-T-E, as you can see on the screen, comprises of 8 bits. And well, I don't want to go far. I just want to chip in that, in computer memory is arranged so that they are in 8 bits. So a byte is made up of 8 bits. So 10 bytes, you should know what the equivalence in bits. And a bit, as I have already said, can represent only 2 distinct values, 0 and 1. Whereas a byte can represent 256 combinations. Let me see whether I can draw something here on your screen. Let me try and draw. Okay, I can write something. Yeah. So I said a bit, B-I-T. I'm writing. A bit can represent only 2 distinct values. A bit can be 0. A bit can be 1. Only distinct. But a byte is made up of 8 bits. So see now, this is a byte. 1, 2, 3, 4, 5, 6, 7, 8. This is a byte. Let me write another byte. 1, 2, 3, 4, 5, 6, 7, 8. You can write your own, provided it's 0 and 1. I can start 0, 2, 3, 4, 5, 6, 7, 8. Continue writing your own different combinations. So I'm saying that if you count, you are going to get up to 256 unique combinations of a byte. And this 256 is 2 raised to power 8. That's mathematics, because 8 bits is making up a byte, so 2 raised to power 8 will give you this. While in bit, you only have 2 combinations, 0 and 1. In a byte, you have a byte can represent 256 combinations. I just wrote 3 combinations. You can still get 256. If you like, I can stop the lecture and wait for you to write them all down up to 256. But of course, I'm joking. So that's a byte and bits. So I'm done with this. I'm moving on. So if you don't understand, read it more from your manual and from online sources. I can only add that a word, W-O-R-D, it's made up of 2 bytes. That's also a known, a known knowledge. So that means a word is made up of 16 bytes. It'd be 16 bits or 2 bytes. All right. We move to the next, binary representation. Let me clear what I've written here. Binary representation for those joining. See, let me go back. We have looked at bits and bytes. We are now going to binary, this one, binary representation. Okay. The binary system, as you can see on the screen, is a way you represent data using combinations of zeros and ones. Your name, for example, Sophia, can be represented in a binary system. Your name can be converted. There is a table for character encoding that is used to what? And we are going, the next slide is even on character encoding that is used to change someone's name or anything written, or even images, audio, and video, change them into what? 0 and 1. So interesting. But that's the only language the computer understands. So that video you're watching, that YouTube channel you're watching, it is being brought to you from the computer memory as zeros and ones. So the binary system provides a way to represent data using combinations of zeros and ones. And the binary representation is the foundation of how computers process and store information. And you guys might not know, some might know that computers operate using what we call electrical signals. And by the way, you know, computer science came out from electrical engineering. Electrical engineering was older. Then computer science was born from electrical engineering. So computers, they operate using electrical signals. And electrical signals can either be 1, which is on, or 0, which is off. An electrical signal, either you on it, which is 1, or you off it, which is 0. So all data, call it whether numbers, text, images, sounds, must be converted into binary form. Because the computers operate with electrical signals. So I've said all I can say for now on this, that the binary representation is about the method of representing data using only 2 digits, 0 and 1, and which serves as the fundamental building block for all digital data in computers, and acting as a foundation for how information is stored and processed within digital systems. So each 0 or 1 is called a bit. And the combinations of bits represent numbers, letters, images, and other data types. Okay. That's all for this. Any other thing I'm forgetting here? No. Okay. All right. So we move on to the next. Character encoding. Character encoding is a system that assigns a unique numeric value to each character in a set, you know, allowing text to be stored and transmitted electronically. That is, when we talk about character encoding, it talks about assigning unique numbers to characters. This is the value it is in decimal format, or this is the value in binary, this is the value in hex format, this is the value in octal. Capital A has a different value, small a has a different value. Capital T has a different value, small t has a different value. And also other signs and symbols like question mark, quotation mark, they all have their unique numbers assigned to them. So you'll agree with me, if these characters have unique numbers assigned to them, that means any character can be converted into numbers. So if I say that A on the screen, I know it's tiny. I just brought it here. This is just an example of character encoding. There are different character encoding methods out there the computer uses, but this one is just the ASCII, ASCII code table. If you look at this screen, I know it's tiny, and you want someone's name is Abu, A-B-U. Capital A, you can see the number is 65. Capital small b, if we were writing the name as capital A, then B-U, small, Abu. So small b will be 98, and U, small u, will be 117. So you can now write out the person's name, Abu, but that will be in IC code. So that numbers, you will have to convert them to binary. Reason is because the computer understands only binary system. So Abu A, that is 65. 65 is a decimal number which should be converted to binary. And you're going to get stuff like 1, 0, 1, 1, 0, etc. And well, the binary is even there. So the binary equivalent of 65 on your screen, capital A, is 01, 00001. Small b, 011000, etc. So you can imagine Abu combining those three binary numbers, and that will be the person's name. So this character encoding determines how characters are represented in binary form on computers. So your name is represented in a binary form on computers. Name of place, name of anything, text, audio, image even. They are all represented in binary form on computers. And we have a common character encoding ones like the ASCII, ASCII, American Standard Code for Information Interchange. That's the most common used by computers. You also have Unicode. Unicode have different subsections. You have Unicode. You have a numbers assigned to them, this Unicode. So, but Unicode is the general name, and it's a very, very popular character encoding method. So we have others, of course, but let's just give these two as an example. So I believe we understand what they are doing. They assign unique numbers to each character in a sense. And when we say character, we're also talking about symbols, signs, quotation marks, all those marks, question mark, apostrophe, semicolon, colon, and the rest. Okay, that's about character encoding. Let's move on to the next, numeric representation. These should sound more familiar and easier. So I give us 5 seconds to read what is on the screen. Seconds. Five seconds. All right, my 5 seconds, of course, I read 20. Okay, I'm reading on the screen. Numbers can be represented using various numeral systems. You have your binary decimal, that's the zeros and ones. You have the decimal number system, which is what you call in secondary school base 10. You have the octal, base 8. You have the hexadecimal, base 16. So these different bases are useful for different applications. So when we say numeric representation, we are referring to expressing information or your data using numbers. Simple. Of course, instead of words or other forms, but using what? Numbers. That's numeric. It's a way of quantifying or symbolizing things to make them easier to process, analyze, or compare. When things are in numbers, it's easy to process, analyze, compare. All right. People are busy chatting, and it's a little bit distracting me. If you know a way to stop chatting, please let me know. You can send me a private message. I've never even talked about that. Okay. Okay, I think I've gotten it. So sorry for the talkatives here. If you want to talk, create your WhatsApp group and start talking there, not during lecture. So I just said to catch clues. When exams come and go, how I wish I would have the time to also do another lecture. Let me now follow you and be catching clues. So I think I've disabled, that's on Zoom. I can't do much on YouTube, though I can also disable that of YouTube, but I don't have the time now. Why I'm disabling the one here is because it's distracting me. Once a while, the window pops up on my screen. Once a while, it pops up on my screen. So I had to disable it so that people will stop making noise. All right. So we move on to the next, text representation. Text representation. I've written what it more or less means on the screen. That's of all the grammar you're seeing on the screen, it simply means representing your data information using text. That's all. So it's all about expressing your data, concepts, ideas, using written words, sentences, and symbols, as opposed to using numbers or images, visual forms. So it is a way information is conveyed in a readable reading. It's text reading in a readable understanding format using a language. I come again, it is a way your information or your concepts or your ideas is conveyed or are conveyed in a readable understanding format using a language. That's English language, Yoruba language, Hausa, Igbo, French language. So essentially, text representation makes complex data more accessible, offering clarity and meaning through your language. So that's all for text representation, converting your data into a written format. The next is image representation. Image representation. I think all of them are just self-explanatory. We are just trying to fulfill all righteousness. That involves expressing your data, your concepts again, your ideas, using visual elements, such as pictures, graphics, diagrams, or any other visual media. So this image representation translates information into a format that can be interpreted through visual perception rather than through text or numbers. And images, if you know more about images, you will know that images are broken down into pixels. And each pixel has its own particular color value. So, but we are not going deep into that. The takeaway here is that image representation is all about expressing your data, your concepts, your ideas using what? Visual elements, such as graphics, diagrams, pictures, and any other visual media you can talk of. The next is audio representation. Audio is also self-explanatory. It's all about conveying data, your concepts, your ideas through sound. So this form of representation utilizes spoken language, music, sound effects, or any other auditory stimuli to communicate information. So making it accessible through hearing, ear, rather than through sight or touch. So the audio representation is accessible through hearing and not through seeing or through touching. That's for audio representation. For video representation, the same explanation. I will just remove anywhere I say audio, I will put video. That's all. So video representation, let's start again, involves conveying data, concepts, ideas, using what? Moving images and sound. I believe most of us should know what is video. Video is what? Moving images. Images that are moving. That is what do you call it? Video. If you move images, you have video. You have your images, collect them, let's say 1,000 images. And if you're able to use the technology to make them move, then you have created a video. So that's sound. So that's the audio for you. So audio is for representing your data, concepts, or ideas using moving images and sound. Sound is that it's somehow now for you to watch a video without sound. Yeah. So video is often used when the information is complex, or it is time-based, or when both sight and sound together can offer a clearer understanding. So it's one thing listening to Davido's songs It's another thing watching the video with the sound. So he said that the video is often used if both seeing and hearing together would offer a clearer understanding, or when information is complex or it is time-based. So that's where video representation might come in. So remember that video is what? Moving images. The next, data structures, we now enter into more abstract ones that will be a little bit hard for you to understand at this stage, but we still have to try and pass through them one after the other. Now, data structures are ways of organizing and storing data so that it can be accessed and modified efficiently. There are so many ways, but I just listed 4 on your screen. Arrays, linked lists, trees, graphs. This tree is not the mango tree you have in your house. These are abstract ways computer arrange information in its memory. There are different ways it can arrange any information you give computer. It can arrange it in a form of array. It can arrange it in a form of linked list. It can arrange it in the form of trees. It can arrange them in the form of graphs. There are other many ways, hash tables, etc. So all these you are seeing on the screen are called data structures. So they are ways of organizing and storing data in the computer so that it can be accessed and modified efficiently. So these data structures, they provide a systematic way to manage and process data for various applications, ensuring that operations like searching, inserting, updating, and deleting can be performed quickly. That's the good thing with data structures. It's a way computer is arranging whatever you are giving it in its memory. So that way it is arranging it is to make it easier for the computer to access them, to do whatever it wants to do with them, to process them, to search and locate them easily in its memory. Else, if it's just dumping everything on its memory anyhow, it will be very difficult to access one particular data or one particular information in its memory. So data structures, they are what? Ways of organizing and storing data so that it can be accessed and modified efficiently. The next is database representation. If you know what is database, then you know what is database representation. So it's all about the way data is structured and stored and organized within a database system. I'm not saying within a computer, within a database system, so that it can be efficiently retrieved, managed, and manipulated upon. If you know what is database, and database stores information using tables, and those tables have rows and columns. And by tables, I mean abstract tables. I don't mean that table on in your room. Okay. And databases, they store information in a way that makes it easy to perform operations. Which operations? Querying, updating, and ensuring data integrity. Query means searching for something, or you want to update the information you have there. So database organizes them in form of tables. And let me just draw one thing to show you what I mean by tables. I'm drawing on the screen. It's not allowing me. Okay. You have a table, maybe matric number here. The table is called students, matric number here. Let me see, age is here. Then the next one is gender. We just call G. Gender, male, female. Let's say state of origin, etc. State of origin. So this is a table called students. And there will be many. 1, 2, this serial number, 3, etc. Like in science, you guys are more than 1,000. So let's say 1,500 from 100 level. Students 100 level. Now, everybody, their name, matric number, age, blah, blah, blah. Now, if you want to get a details about a student whose matric number is 2, 4, blah, 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 at the end, 6. So query means you type that matric number, and that's exactly what we are doing. I said, yes. You type that matric number and it will give you details about that student. Whether it's a son of a native doctor, it will show there. The religion, it will show there. Age will show there. Gender will show there. Whether you're on rustication, it will show there. Everything about the student will show there. So you see, it's so easy because it's in a form of a table. You just type matric number. You can imagine if there was no way to type matric number, what will happen? So you have to be passing through the 1,500 students to look for the person you are looking for, to search for the person you are looking for. All right. Okay, so that's about database. I'll move on to the next. Graph representation. Simply, displaying data using a graph. So the only thing is to know what is graph. Graph is like an entity that has what we call nodes, N-O-D-E-S, and edges. Nodes are called vertices. Edges are called links. Let me quickly draw a graph. Okay. This could be a graph. Let me use another color to join them. So this could be a graph. So here, the red circles are the nodes or the vertices. And the blue lines are the edges or the links. So graph representation of information is a way of structuring and organizing data using graph theory. Yes, I have not done graph theory, you don't understand. But I'm trying to break it down to a layman's level. So in graph theory, the data entities are represented as nodes, and the relationships between those entities are represented as edges. So this presentation is particularly useful for modeling complex interconnected data, such as social networks, web pages, transportation systems, and so on. For example, social network. This red could be users. The red could be users. The blue line could represent relationship between the user. That's whether you are my friend on Facebook or not. So the red could be users on Facebook. Let's say there are only 4 users on Facebook, and these are how they are interconnected. It means this user here, marking X, has 2 followers, or you can call it has 2 friends on Facebook. It means this user marking good has 1 follower on Facebook or has 1 friend on Facebook. So you see, we have used graph to represent a kind of a relationship. So that's the key word there, relationship. So you can also come up with other examples. I've just used social network. You can also come up to web pages. If a website has 4 pages, it means that from the pages are represented by red. The blue is represented by the link between them. So if I look at the page, I wrote X inside. It means that from this X page, I can go to 2 pages. I can go to this page, I can go to that page. Just like when you're on Unilag website, from that home page, maybe you can go to admissions page, or you can go to the news page. So these are ways, you see, these are information, are concepts, are ideas. They are being represented using graph. And what comes to mind is relationships. And relationships are the links linking the nodes, the vertices. So the next is the Boolean algebra. So Boolean algebra is a branch of mathematics that deals with variables that can have one of 2 possible values, true or false. So in Boolean, we're talking about it's either this or this. It's either 1 or 0. It's either true or false. So, and it's used to manipulate other logical statements using operations like and, or not. If you have done a set theory in secondary school, I believe you must have done it, set, S-E-T. You will understand what I mean by and, you will understand what I mean by or, and you will understand what I mean by not. So that's Boolean algebra. It's talking about what? Variable that can have 1 or 2 possible values, true or false. The next is machine code assembly language. Nothing more to say here because we've been talking about machine code since. So machine code is the lowest level programming language. Remember, we have low-level programming languages, so, and they are mostly two, machine language and assembly. So among the two, machine code is the lowest level, is the lowest among the two. Both are low-level programming languages. And we did low-level programming languages in our first lecture with me. So the machine code consists of binary instructions, which are what? Ones and zeros. That the computer's CPU can understand and execute directly. So, and it is the only language that is directly understood by the computer hardware. The only language that is directly understood by the computer hardware without needing any translation. Unlike the assembly language, unlike the high-level languages that must be translated by our translators, the compilers, and the rest, interpreters. And machine code instructions are represented in binary. I've said this and this and this again. And each instruction corresponds to a specific operation. So any instruction can be like adding numbers, or moving your data from one memory block to another, or jumping to different parts of the program. So, and secondly, when it comes to assembly language, the second one on the screen is a human readable representation of machine code. It's a low-level language, yes, but it's a little bit more understandable to a human than the machine code, which is purely zeros and ones. So it uses what we call mnemonics, that's symbols, to represent binary instructions, for the CPU. So why it is still a low-level language, that's assembly, it is still far easier to read and write compared to machine code. So this is another way information is represented. Then the next, I think, second to the last, is semantic representation of information. Semantics, if you know what is semantics, it's all about digging for the meaning of something. So semantic representation of information refers to how the meaning of data is captured and structured so that it can be understood, processed, interpreted by both humans and machines. How the meaning of data is captured and structured. So unlike syntactic representation, syntactic focuses on the structure and form. Syntax, the structure and form of data, unlike that syntactic representation. Semantic deals with meaning, the meaning behind that data. So ensuring that the relationships, context, and intent are preserved and accurately conveyed. That's semantic representation. And finally, for those that were having D or E in maths, okay, wait, none of them are here. Yes, you can't get admission at B without at least a C. So for those that were having C in maths, if you see things like this, you want to run away. Limits, integral, equations, system of linear equations, etc. So when we talk about mathematical notation, we're talking about them. So symbols, concepts, etc. So mathematical notation is a system of symbols to represent mathematical operations, mathematical relations, mathematical concepts, and numbers. And therefore, it allows for concise and accurate expression of complex ideas and formulas through a combination of letters, figures, and special symbols. That's the power of mathematics. You can use equation to represent a very complex idea. You can use a formula to represent a very complex idea. Like the Newton's laws, the Newton law 2. Very short formula, F is equal to MA. But when you start to explain it, you see that, man, force is equal to the product of mass and acceleration. I hope I'm correct. So mathematical notation is all about system of symbols, used to represent mathematical concepts. So equation comes into play, so mathematical notation and others. So let me go back. We have taken all these, taken them one after the other. including the second page, one after the other. So before we go into doing some solving now, hope I will have time, there's time. So let me give you 1 minute to recreate yourselves. Let me enable you to chat yourself away for just 1 minute. Okay, so you're free to recreate yourself for 1 minute, while I'll also entertain you small. So the boy in my house is my small boy. I take care of him. He's been with us since he was small. He was with my dad. When I came back, my dad was traveling out. He said, this boy is good, take him. Oh. So I took him, he came along with me. So he's already almost graduated. I wouldn't call where he's coming from. I wouldn't call his department. I wouldn't call a faculty so that I will not go and be yadding him. But he's a diehard Real Madrid fan. Since start today, he has been telling me that they will fire that referee. They will fire that referee. And I said, okay, let's wait till Monday now whether they will fire him. Because he gave you guys red card. Therefore, they will fire him. You are not serious. That Ancelotti has been complaining. Real Madrid people have been complaining that the referees are not good, that they prefer them coming from Real Madrid, from Premier League. But they came to Premier League. Yes, granted, they defeated Man City. But at the same time, they were complaining of the referee there too. So I'm so sorry for him because he knows when I come back to that, I'll ask him, have they fired the referees? Yes, I looked at the match. I didn't watch the whole match. I looked at it, but you know now, enemy. I'll be happy of what I'm seeing, even if they are, dealing with them in a very unfair manner. But I was very happy, really. It made my day. The red card, as far as I'm concerned, whether I'm a fan or not, to be fair, that red card stands. Because you can't talk back to the referee. And I think he even used the F word. Even if it's not using the F word, you can imagine you being a referee and somebody tells you, you get your sense they correct, they see, you blind, talk less of F word. Or a student coming to tell me that. As the student is telling me that, I will just bring out his exam sheet and say, you are getting F. Go and report where you want to go and report. So I believe that it's a matter of the, character that led to that red card. So he should even go to church or to mosque and go and give thanksgiving that they did not defeat them. What if they defeated them? It's only not the referee. The head of La Liga will also be sacked. So I know Real Madrid fans, you guys will always complain. We are very happy. The whole world is happy. So we are waiting for Barcelona. Or has Barcelona played? I don't even know. Atletico Madrid, they got a draw, and you guys wanted them to join you to start complaining. They did not complain. So carry your headache, please. We don't want you to carry La Liga. So go and rest. All right. I've helped you guys a little. You deserve it, Sha. And mind you, that boy, he's also a Man U fan. So when Man U were playing bad, he denied. No, I'm not a Man U fan. It's just that in Premier League, all of them is because of Ronaldo that I'm a Man U. It's not true. When Man U is winning, you see him jumping and praising. But when Man U is losing, you will not see him around. He will just disappear. So, Man U fans, I'm greeting you, but today we are on top of Real Madrid matter. So please, once you hear that they have sacked any referee, let me know. So if they don't sack any referee, then we know where shame is going to. All right. So I will be, yes, I know Chelsea were defeated, but at least we know they make noise. They defeat us, we just go home quietly. But your own, they defeat you, both Man U, both Real Madrid. You start saying referees this, referees that. Referees this, referees that. Can I carry your wahala go, Joe? All right, so we move on to lecture. I will have to remove the chat. I know that they are catching their cruise on YouTube, but please listen. Please listen. Where do I start? This is here. Should be on computer number system. When we talk about computer number system, we are talking about a way of representing numbers in a format that computers can understand and process. And I told you that computers operate using electrical signals. So since computers operate using electrical signals, they primarily use binary number system. Electrical signals are just two. You either on it or off it. So 0 or 1. However, for human understanding and convenience, other number systems are also used in computing. So we cannot just be using binary system, both computer and humans. Binary system will be very hard for you and I to understand. Therefore, we need other number systems to be able to understand what the computer uses. So that's why you have the decimal number system. That's why you have the octal number system. That's why you have the hexadecimal number system and all that. And binary system, of course. So we look at the 4. And so bring out your pen and your paper. We'll do some solutions, but that's in the next 4 slides. The examples of number systems. You have the decimal number system. It is the most popular because that's what the most popular among humans. That's what you and I use every day, counting money, counting anything. Then you have the binary number system. You know what it is. You have the octal number system, the hexadecimal number system. So the next slide will just explain what they are. Brief summary of each of them. So, shall we go? The next should do that. So the decimal number system uses digits from 0 to 9. An example is 456 base 10. You know, this base 10 means just the normal 456 me and you know. 20 base 10. It means the 20 me and you always use every day. So it is used in everyday human calculations. So octal, let me go to octal number system. It is called base 8. And it uses digits 0 to 7. Example is 27. So if you see 27 with this subscript 8, it means base 8 too. It means octal number system. So, and 27.8 is an octal representation of decimal 23. So that means you have to know how to convert from decimal number to octal and from octal to decimal. The usage is shortened representation of binary numbers in computing. The next one is hexadecimal number system, is base 16. Uses digits 0 to 9 and characters A to F. A means 10, B is 11, blah, 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 F is 15. Example is this number. It's a hexadecimal representation of decimal 419. So your work is to find out how this was converted 419. We are going to do some conversions, yes, but our conversions will just focus on these two. Let me do a diagram on this screen. To focus on these two. Decimal to binary and binary to decimal. But you are expected to learn this. Decimal to octal, octal to decimal. And these two. Decimal to hexadecimal and hexadecimal to decimal. Their conversion. So I will do the blue one while I leave the harder one for you to do. I hope I'm a good uncle here. So these are the most, popular or the most common computer number systems out there. And the most popular among humans is the decimal number system. And I've told you why the number systems are needed. Because binary alone, which is used by computer, will be extremely difficult and hard for us to understand. Why? Therefore, we need other number systems. One of them is decimal number. So if I say I will give you 10K, you understand what it means. But if I say I will give you 0111010K, you don't understand what that means. Okay, so we move now to our conversion. So I don't want to waste time here now, since you're going to get this slide. So whenever you get it, you read what you're seeing now. What are you seeing? We are doing 4 conversions. Open your ears very well. We are doing 4 conversions. Can I write? Will you allow me to quickly write? Just will take my time. One is decimal. No. Use it wrong. One is decimal, whole decimal to whole binary. Another one is decimal fraction, a fraction to binary fraction. The next is, now we go to the opposite way, binary to decimal. And finally, binary fraction to decimal fraction. What I mean by, you know what is fraction now? 1/2, 0.345. These are fractions. So these four I listed, this is what you're seeing on the screen, the descriptions. So the first one is to convert a decimal number to binary. You can divide the decimal by 2 repeatedly. Yes, we go through it now. The decimal number to binary. So this one goes here. Let me change the color. This one is this, explaining how to do it. To convert the second one, to convert a binary number to a decimal number. Okay. Let me use another color. So this one is here. Third one, to convert a decimal fraction. Okay. This one will go here. And the last one, of course, goes here. So it's just explaining what to do. So I'm just going to do some assignments now. I will open a whiteboard, do quickly. I'm looking at time, it's really going. But we'll meet up, shall we meet up? So before I open a whiteboard now for us to do some solution solving, let me show us the next screen. So look at this. We looked at it. I'm now going to the next screen. Take home, the harder one. The take home is what? Learn how to convert decimal to octal, how to convert a decimal number to an octal number, and learn how to convert octal number to decimal. Second is learn how to convert decimal to hexadecimal, and how to convert a hexadecimal number to decimal. These are your take-home assignments. You don't need to submit it, but you'll be glad you did and understood it. So trust me on that. Okay, so let me open a whiteboard. So I'll be stopping this slide for now. Yeah, to enable me go for whiteboard. How do you get the whiteboard now? Come in. Okay, I think I'm opening. Okay. Okay, let me enable chat so that I can ask questions there. No, can even ask it on, please, on YouTube, if you can see the whiteboard, a white screen, just say, yes, I can see. On YouTube, please. Well, let me go and open my YouTube. I did not even open it. Okay. There's so many charts on YouTube that to follow is very difficult. Okay, well, if people on Zoom can see, because there are so many messages on YouTube still, okay. I can hear you. You can see my whiteboard fine. Thank you. I want to make some settings to enable. I wouldn't want people to be touching the whiteboard and be, how do you set that? Lock. Let me see. If I lock it, can I do anything on it? You're about to lock the whiteboard. Locking the whiteboard removes viewing access for everyone or owners. No. Let me know. I'm still with you. I'm just trying to set up the whiteboard well so that when I'm writing, it will not start. Log background color, move to trash, rename, move whiteboard to project view, please, comments, votes. Okay, I don't think I was trying to see where I can lock it so that, so that people will not be touching on the screen. Okay, no problem. We move on. See how it goes. Now we are doing 4 conversions: decimal to binary, binary to decimal, decimal fraction to binary fraction to decimal. Of course, I'm going to take easy numbers so that I will not go and fumble before students and say, hey, this man doesn't know how to solve it. So, and it will be appearing everywhere, both on YouTube. But who doesn't know how to convert? So let me generally took easy one I will do and go. Okay. So I will enable chat in case you would like to ask a question on this particular one I'm going to solve. Okay. Okay, so let me start. Let me write a number. Let me just take a number. Easy ones now. That's the one I will do quickly. 44. We want to convert the number 44 to binary. Typically, if it is an exam, that 44 will be like this. 44, below it 10. To tell you it's base 10. Base 10 means the number you and I normally use. But if you don't see the 10 below, then watch the instruction. Instruction will say convert decimal number 44 to binary. So you know it is. Please make sure you are seeing the whiteboard. Make sure you are seeing the whiteboard. Okay. So the 44, what does that slide tell us? The slide says to convert a decimal number to binary number, you can divide the decimal by 2 repeatedly, recording the remainders until the quotient is 0. Then write the remainders in reverse order to get the binary number. Okay. So let's divide 44 by 2. Let me write 44 again here. And let's start dividing by 2 the way I know. 2. Let me cross it this way. Okay. 44 divided by 2 is 2. Remainder 0. Remainder 0. Or you can start your 0 here. It doesn't matter. It doesn't really matter. It does not really matter. Trust me, it does not really matter where you start your 0. Up or down. After all, you're going to pick it from down. 22 divided by 2 will be what? 11. Remainder 0. 11 divided by 2 will be 5. Remainder what? 1. 5 divided by 2 will be 2. Remainder 1. 2 divided by 2 will be 1. Remainder 0. And 1 divided by 2 will be, it can't divide it. That's how we say it. It can't divide. So it can't divide. How do we put it now? I know what I'm going to write, Sha, but I want to know what I will write at the middle so that I don't confuse you. So 1 divided by 2 will not go. So that 1 will remain until the quotient is what? What did they say quotient? I'm using the division. Repeatedly recording the numeric until the quotient is 0. So it's 0 that we are getting here. 0. Let me write it below here. 0. So 1 divided by 2 will be 0. Remainder 1. Let me put it that way. Now the answer, the binary equivalent of 44 will be, you pick this number. Let me take another color. Where is the color again? Where do we get the color? Yeah, here. Will be these numbers, down, up, reverse order. These numbers, reverse order. So that will be 1, 0, 1, 1, 0, 0. I can put 2 here, means base 2. So 44 base 10 is equal to 101100. I've done it. I will quickly do another one. Very, very quickly do another one. And then we move on to, after doing another one, it will be said that I've done decimal to binary. Quickly do another one. So I hope you wrote, I'm clearing the screen board, or can one open a new one? Let me see. Yeah. Okay, one can open a new one. Okay. Let me pick a number by myself. Well, this one is so easy. Let me pick 23. So I might be old school, how I'm dividing my own. You know how you divide your own. Well, we're interested in the answer. So convert 23 to binary. Convert 23 bits 10 to binary. Convert decimal number 23 to binary. Any way it comes. 2. 23 divided by 2 will give you 11. Remainder 1. 11 divided by 2 will give you 5. Remainder 1. 5 divided by 2 will give you 2. Remainder 1. 2 divided by 2 will give you 1. Remainder 0. 1 divided by 2 will not go the way you write it now. So 0. Remainder 1. So remember, we always stop when the quotient is 0. See this quotient. We always stop when the quotient is 0. So the answer will be reverse order. That will be 1, 0, 1, 1, 1. So that's 23 in binary. It's doing, most of you will know this already. But remember, under exam condition, you got to be pretty fast. Trust me, you got to be pretty fast. Else, you can see a question that says 2 plus 3. But because you have 2 seconds to do it, you forget that it is 5. Okay, so this is decimal to binary. So I'm going to open another slide now to do binary to decimal. So I'm opening. So let me peep at the screen on YouTube. I hope things are happening there. Okay, I can see what I'm doing is there. Fine. Okay, let me open a new. Now I'm opening a new whiteboard. We want to go do binary to decimal. Or how do we go? Do we finish decimal to binary before we move to binary to decimal? What do you want? We have done decimal to binary. Do we do decimal fraction to binary fraction before we now move on to the opposite direction? Or do you want us to touch binary to decimal? You are free to comment. Okay, you want us to do fraction. So I've been trying to look for a good example because a good example very matters. Else, we will not go home here today. A good example really matters. So don't bother saying, sir, no, we'll give you a difficult example. If you give me, I give it to you on exam. Simple. So, but why I'm saying a good example is if you take a difficult one, you will keep on calculating until the day is gone. So let's do the fraction. I want to use a number that is easy to go. Okay, let me see. 0.250. On the slide, it was written that you keep on, you multiply the fraction side by 2 repeatedly until that fractional part is 0. Then you can write out the integer parts from each multiplication in reverse order. So 250, 0.250. So ladies and gentlemen, we are doing what? We are converting decimal fraction to binary fraction. So keep on multiplying the decimal part by 2 until everything is 0. So we multiply times 2. 2 times 0, 0, 2 times 5, 10. You pay school fees to be learning how to do 2 times 5, 10. 2 times 0, 2 times 5, 10. Carry 1, 2 times 2, 4, plus 1, 5. 0. All right, we'll move on. So let me use red to mark this. We multiply again by 2. Sorry, should be black. Multiply again by 2. 2 times 0, 0. People are saying they can't see anything. Can you see my whiteboard, please? Can you see my whiteboard? Yes. So if you can't see my whiteboard, it is from your own side. It is not from me. You can see many people are seeing it. It is from your own side, from your phone. Buy a new phone, you will not buy. Always carrying your phone around. That's why you are not seeing it. Check the settings well. You don't even need to do any settings. It's just to open your Zoom and it will just show. So 2 times 0, 0, 2 times 0, 0. I don't have the time again. 2 times 5, 10. 0.1. And it says stop when the fraction side is 0. So the answer will be, listen, since it's a fraction, since it is a fraction, have you heard my explanation? Since it's a fraction, so it must be 0. Since it's a fraction, I've not touched anything here. I've not. Just since it is a fraction, it will be 0. Then you move down up. 1, 0. Since it is a fraction, right? 0.10. Okay. Let me do another one quickly. You see, I have to choose a number that will enable you end on time. Else, if I give you a number, just be multiplying by 2, your time will go. So I want to check a number that can, how do I go now? Let me check another simple number that will enable us. I'm coming. I'm just looking at. Okay, let's say the person that asked, what if we have 5.000? 5 is not a fraction. Remember, we are converting decimal fraction to binary fraction. 5 is not a fraction. So let's just do one more. 0. I'm writing on the right side of the screen, 0.125. Convert this decimal number to binary number. So in exam, you might not hear decimal fraction. Who is coming to tell you that it's a fraction? You should know that it's a fraction. So why did I say it's 1.0? See now, I've multiplied. You have to be multiplying by 2. Okay, let me leave it here. If you don't know how I got 0.10, listen to the next one I'm doing now. They are similar. Listen very well. Remove your eyes from chat. People are just chatting and writing their life there, writing their matric number. Listen to what I'm saying. So if you understand the second one now, the first one will understand it. The question is convert 0.125 to binary. So the conversion, you have to multiply by 2, continue to multiply by 2 until the fraction side is 0. So let's start. So be listening so that you wouldn't ask me how I got the answer. 2 times 5, 10. Carry 1. 2 times 2, 4 plus 1, 5. 2 times 1, 2. Here is 0. You mark your 0. So you see me, I've marked my 0. Okay, you continue to multiply by 2. 2 times 0, 0. 2 times 5, 10. 2 times 2, 4, 5. 0. You mark your 0. Okay, next one, you multiply by 2. 2 times 0, 0. 2 times 0, 0. 2 times 5, 10. Carry 1.1. You mark your 1. And we stop. So those that didn't understand, why did we stop? We stopped because the fraction side is all 0. That's the rule. You stop when the fraction side is all 0. So when you pick your answer, you are picking from down up. Listen. However, that's where you did not hear or you did not understand. However, what are we doing? We are converting a fraction. This number is a fraction. 0.125 is a fraction. Therefore, your answer should be 0.25. to start with, 0 points. I have not touched the answers I got to. Since it's a fraction, you must start with 0 points. Then you pick all these green. 1, 0, 0. I hope it's clear. So if you can't see your screen from Zoom, go to YouTube now. It is there. Let me paste the YouTube link again on the chat. Let me paste it many times. So I'm pasting the YouTube link many times. Sorry, I'm pasting it to one girl like that. That wrote me. So I've pasted many links. The same, YouTube. Go there and join if you cannot see. If you cannot see, I've posted. So these are 2 examples. I remember I'm recording this. So at the end of the day, when you get the record, make sure you come and watch how I did 0.25 and 0.125. And I got the answer. So how did I go 0 point? 0 point is because it's a fraction to start with. Okay. Now, your assignments, listen and listen carefully. If your village people is around there, tell them that they did not see you. Listen and listen very carefully. You know, we all love you guys. We want you all to pass because I will not gain anything if you fail. Or if you've passed, who knows? Tomorrow you can say, so I bought you a house at Lekki. Come and take it because I got A in COS 101. So it is on our own interest that you pass. However, they said you can take a horse to the river, but you can't force it to drink. So if you have sworn that you don't want to pass, then it's unfortunate. We can't do anything in that case. So, but listen, please, to assignments I want to give now. Remember, I'm writing, let me write here on top. We have converted 44. Abi? And we have converted 0.25. You want put 0, it doesn't matter. Now, what if the question is convert 44.250? What if the question is like this? What happens? What if the question is convert 44.250? We have converted 44 in our first one. We have converted 0.25. So what are you doing? Can you remember what we got in 44, ladies and gentlemen? I want you to say it by yourself. Can you write it? What we got in 44 when we converted 44. 101100. Thank you. So when we converted 44, we got 101100. And when we converted 0.250, we got, see it here, 0.10. 0.10. So to solve this that I'm circling now on top, you just add what you got under 44 to what you got under 0.250, and that's the answer. So what are we doing? 101100 plus 0.10. You add, you get 10.0011101. So that's the answer to 44.250. So if you are given a number that has whole number and fraction side, you convert the whole number the way we are converting them, dividing them by 2 until it becomes 0. You convert the fraction side, multiplying by 2 until it becomes 0. You add, and that's what you will get. I'm done with the decimal to binary, and we have 20 minutes to go. We'll now do the binary to decimal, which is a little bit complex for others, but it's still the same. Okay, you don't understand? Olaoluwa, Elizabeth, listen again. The question is to convert 44.250, right? Convert 44.250. This is a decimal number. Convert it to binary number. So the whole side is 44. The fraction side is 0.250. So we have done how to convert whole numbers. Remember when we did 44? Let me find a little space on your very left-hand side, 44. See, I'm writing 44. Remember when we are converting it, we were dividing by 2. 44 divided by 2, 22. Remember 0. 22 divided by 2, 11. Remember 0, etc. I'm not going to do everything. At the end, we got what? This. 101100. That's number 1. Then we take the fraction side. See this one, 250, 0.250. And we convert it to binary. And this is the binary conversion. See it here, when we converted. This one, fraction, you're multiplying the fraction side by 2, every time by 2. Of course, be keeping track of your whole side by 2 until everything is 0, 0, 0. Once it's 0, 0, 0, that is until the fraction side is 0, 0, 0. Once it's 0, 0, 0, we take our answer 0.10. And that's how we got this second one here below your screen. Then we add 2 of them. This is where we are adding them. The first number, see it. The second number, why is this here? It's a fraction now, 0.10. You add these 2, you will get this. Is it a little bit clearer? Is it a little bit clearer? Okay. Somebody said, okay, somebody said 0.25 is not 0.1. I don't understand the question, but sorry, I have to move on. Say 0.25 is not 0.1. I don't understand what you mean. Yeah, but then at the end of the day, what are you doing? Even if you are confused, what are you doing? You are converting decimal to binary, and that whole number carries a fraction. So convert only the whole number by dividing by 2, 2, 2, 2 until 0, 0. Then convert the fraction side by multiplying by 2, 2, 2 until 0, 0. And then, you know, add them. Add them, and that's all. So, but you can practice it. So I like that you're asking questions, you're trying to find out. That means you can practice it after this lecture. Don't go to Instagram. Don't go to TikTok. 20 minutes, try to convert 250 again, 0.250. Don't take another number. Take exactly the number we did. Also take 0.125. Also the very first example, 44. Try them and see whether you will get what you are seeing on the screen. You get the record. Now check and test whether what you did was what you get. All right, thank you. So I'm moving on. I'll open another screen to new screen. Now we are going to now do the opposite, binary to decimal. You have a binary number, you're converting it to decimal. But let me go and peep how to do it before I come and do the wrong thing. Okay, it says what? I'm reading on a slide, but you are not seeing the slide. I'm reading it now. That to convert a binary number to a decimal number, you can multiply each binary digit by the corresponding power of 2. Then add the results together. Okay. Now, let me state one thing. Someone is saying, is there another way to convert 44.250? There are other ways, and you are free. You are very free to explore other ways, my dear. You are very free. Use other ways you believe are faster than you. At the end of the day, we all want a solution. So the way you get to the solution might be different ways, but follow the most efficient and the fastest way. So I'm not saying that the way I used is the fastest. There could be other ways, except using the calculator. Okay, so binary. No, I've not written anything on my whiteboard. My whiteboard is still white. So let me write something on the whiteboard now to be sure you are seeing it. I've written something on the board. I believe you can see it. Hello. All right. This one is a little bit complicated. I have to also take carefully and take a number that can go quickly. So let's get a number. Let me just write any number here. Binary number, right? 1, 0, 1, 1. A binary number. So convert this binary number to decimal. So let me spread it a little. 1, 0, 1, 1. Let me spread it a little. So you find the powers of 2. So this class is not a mathematics class. So don't expect me to be explaining how to add, what is power. So those ones should be your headache. Okay, so this on top here is 2 raised to power 0. On top here is 2 raised to power 1. On top here is 2 raised to power 2. On top here is 2 raised to power 3. So we are multiplying each of these binary digits by the corresponding power of 2. Then add the results together. So we are multiplying anywhere you want to start. Let's start with this one. This one I've circled. Let's start with this one. After that, we do this. After that, we do this. After that, we add this. Okay. So we are starting. Let's start with the 2. So this will be 2 raised to power 3 times. I'm just taking my time to show this clearly with colors, making it beautiful. It's not easy from my own side. Plus 2 raised to power 2 times 0 plus 2 raised to power 1 times 1. Am I done? Okay. Plus 2 raised to power 0 times 1. Okay. Hope everything is clear. Right. Okay. So if you can't see the board, I just quickly went to YouTube to check. So it's showing clearly on YouTube. If you can't see the board, you go on YouTube. So, and I know those not seeing it are Man U fans, always troublemakers. So go to YouTube and go and be seeing it there. So we multiply out. 2 raised to power 3 is 8. 2 times 2 times 2. 2 times 2, 4. 4 times 2, 8. So 8 times 1 plus 2 times 2, 4 times 0. I'm just writing this all out. If you have something in the exam, you don't need to write all this out. You should know what is 2 raised to power 3. You should know what is 2 raised to power 2. And you should know that any number multiplied by 0 will give you 0. So plus 2 raised to power 1 is 2 times 1 plus 2 raised to power 0 is 1. No, any number raised to power 0 is 1. Any number raised to power 0 is 1. 1 times 1 1, 1. So let's multiply. 8 times 1 is 8. Plus 4 times 0 is 0. Plus 2 times 1 is 2. Plus 1 times 1 is 1. So we are getting what? 11. B is 10. 8 plus 2, 10 plus 1, 11. B is 10. Is this clear? You just spread the numbers, put the 2 on top, and we move. Let me bring out another example. We have 10 minutes. I have to do the decimal too, but let me get another example here. Whiteboard, everything you get is on the video record. So I promise to share the video record as early as I can, although after this meeting now we are heading to Idiaraba. So maybe when I come back from Idiaraba, I will look at it. So let me just take a very simple example. 1, 1, 1. You have to convert to decimal. So this is 2 raised to power 0. This is 2 raised to power 1. This is 2 raised to power 2. So this will be 2 raised to power 2 times 1 plus 2 raised to power 1 times 1 plus 2 raised to power 0 times 1. So 2 raised to power 2 is 4. 4 times 1 is 4. Plus 2 raised to power 1 is 2. 2 times 1 is 2. Plus 2 raised to power 0 is 1. 1 times 1 is 1. So the answer is what? 7. B is 10. So this is clear. All right, thank you. So now let's go to the last one. The converting a binary fraction. So 0.111. I think it's better. No problem with that. So if you have to convert it to decimal, it's the same thing we did. The same, exactly the same thing, but you just know your powers. Remember here now is 2 raised to power 0. So after it will be 2 raised to power minus 1. Here is 2 raised to power minus 2. Those that used to run away from mass, welcome back. And here is 2 raised to power minus 3. So what is it going to be? The first one will be 1 times, oh, sorry, let me do this way. 2 raised to power minus 1 times 1 plus 2 raised to power minus 2 times 1 plus 2 raised to power minus 3 times 1. Now in mathematics, let me just write something on the right side of your screen. You know, any number raised to power like 3 raised to power minus 5 means 1 over 3 raised to power 5. 6 raised to power 10 means 1 over 6 raised to power 10. Therefore, let's do. So this will be 1 over 2 raised to power 1 times 1 plus 1 over 2 raised to power 2 times 1 plus 1 over 2 raised to power 3 times 1. So this will be 1 over 2 times 1 will be 1 over 2 plus 1 over 4 plus 1 over 8. The answer, go and find it. You know how to calculate this, either in a fraction or in a decimal. So that's the answer you are going to get. Can someone quickly calculate this? Tell us the answer. Let me write it here. You got 7 over 8. Well, let me write it out. So for those that will be asking, we have 8 here. Here will be 4 Here will be 2. Am I right? Here will be 1. Correct? So we have 7/8. Or 0 point blah, 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 blah. So expect that coming. Okay, that's the last one. So I've seen comments, and I think there's a place we omitted. We made a little mistake. Let me see, and thanks for pointing that out. Let me see whether I can fetch my existing keyboards, the whiteboard. When we are converting decimal fraction to, we took the answers from up. It should be from down. So I have them here. Let me get where it is. It was 250. Yeah. I think it should be this. The guy that pointed this out, everybody should contribute and buy him Coke. As simple as that. Okay. I don't want to confuse all with everything written here again. So let's do 250 again, 0.250 again, and 0.125 again, although time is up. Let me see how far I can go with that. Okay. 0.250. Okay, 0.250. Converting decimal to binary. If you like, call it decimal fraction to binary fraction, but nobody is going to tell you it's a fraction. So we multiply by 2, 0.0. So we keep this. Okay, we move on. We multiply by 2 again. 0.001. We take our 1. We stop. We are stopping because this here is now zeros. We stop. Now, the answer, the way we chose it was wrong. We are choosing from up, down, not from down, up. So we are choosing from up, down. So before you choose, remember it's a fraction. Nobody will tell you that it is a fraction. So it must be 0. Before you now select this 0 and this 1. Wait, my pen has disappeared. This 0, this 0 and this 1. Now, students, can I rest? When I don't yab me enough already, can I rest? 0.01, is this one correct now? Yes, it is correct. For those that will want, let's use 2 minutes and do 125. Another one, 0.125. So I will be pretty quick. 5 times 2. Just let me write what the answer here is. So go and argue with your keyboard how we got 250. So we keep this. And we continue to multiply 2. We have this. So we keep our 0. And we continue to multiply 2. We have 0, 0, 0, 1. We stop. Why are we stopping? Because it is 0, 0, zeros. Not that it is because it's 1. So watch out. So we pick from up, down. Sorry. Since it is a fraction, so 0 at least come in points. Then pick whatever you want to pick. 0, 0, 1. 0, 0, 1. So ladies and gentlemen, this is the correct solution for conversion of 0.250 and for conversion of 0.125. So I think everything is clear now. Those on YouTube, I hope everything is fine. If you have any question, you let your course advisor know. If your course advisor is fighting you, you go for the deputy or assistant governor. That's all. So we are through with my own part. We've covered chapter 3 chapters. That's chapter 4, chapter 5, and chapter 6. Next week, A new lecturer will be entertaining you, Dr. Lucky. So he has a more serious fees. I don't know whether he knows anything about football. So don't expect any joke from anyone. The joke comes and remains with me. So take it serious. I will be sending his phone number. I don't know whether I should send it to the best course rep in Unilag, or do I send it to the WhatsApp group of course reps? Or if you send it to the WhatsApp group of course reps, voila, we start. All of them will be writing him one by one. So I will just choose a course rep. My immediate, the Dr. Gure that taught you, I think he gave it to computer science course rep. I'm from computer science, but since I don't know him, the person I know is the course rep of medical lab, the best course rep on earth for now. So I might send the Dr. Lucky's phone number to him. So Kenneth, when you get the phone number, you do the needful. I did not say that you should go and be negotiating with the lecturer by yourself. You don't have that right. You just try to add him on the WhatsApp group where other course lecturers are. Then he will be posting whatever he wants to post there. I repeat, I did not say you should go and call, sir, how are you? I'm this, I'm that. Please send me the link. No, send the link on the WhatsApp group, because you guys are many, others are from non-science faculties, so they need to get access to the links and to the materials and whatever. So I will send you the link to this lecture and the material. I promise it will be early, but I remember we are heading to Jaraba to go and see the provost of College of Medicine. So that will be when I come back, I share the link and also the materials. So thank you so much. Apologies to all the fans that I must have offended. Apologies to Man U. Apologies to Arsenal. Apologies to who else? Real Madrid. Although we are still waiting for the referee to be fired. And have a nice day. Thank you very much. Bye, everyone.